So in previous sections, we kind of mentioned this idea of limits, written like this, L-I-M, when we were talking about the rate of change or when we're talking about the slope of tangent lines. So what exactly is a limit?
Find the limit of this equation.
If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state.
It turns out that limits is this idea of getting really close to some value and figuring out what the value is at that really close range, okay? So we have to define three types of limits, or three formal definitions of limits. We have the left hand and right hand limits. So it says this: if f at x, some function, gets really close to a finite number L as x approaches a from the left, then we have this weird looking limit definition. And if the function f at x gets close to a finite number L as x approaches a from the right, then we have this limit here. First of all, let's talk about how to actually read these two limits. So this limit is read as the limit as x approaches a from the left of f at x equals L. And the second one is read as the limit as x approaches a from the right of f at x equals L. Okay, so what does this actually mean? I'm going to use this diagram to further explain this. So let's pretend this graph here is f at x, this blue graph. Then let's pick a point A. Let's pretend this is the point A. So if I'm looking at the limit as x approaches a from the left, that means I'm going to get really close to a from the left-hand side. So I need to follow the graph down this left-hand path. So I'm following. As I get super close to a from the left, what does my y value approach? What does my f at x value approach? If that approaches a finite number L, then we say that the limit as x approaches a from the left of f at x equals this finite number L. Same thing with the right-hand limit. So let's say this time I want to approach this a from the right-hand side. Then I'm going to follow along the graph on the right-hand side. So I'm following. Oh, and as I get really close, the y value, or f at x value, approaches a certain number as well. And we say that the limit as x approaches a from the right of f at x equals L. Now it turns out that if these two limits exist and they equal the same number, so the two limits equal, then the limit of f at x as x approaches a, not from the left, not from the right, just x approaches a, is defined, and it also equals L. And we write this limit definition here. So if the left-hand and right-hand limit both equal the same number, then we say the limit as x approaches a, in general, of f at x equals L. Okay? If the left and right-hand limit don't equal each other, then we say that the limit does not exist, and in a lot of cases, teachers in textbook will write DNE for does not exist. So let's take a look at this graph down here. That point A that we just used as an example, the limit from the left and the limit from the right don't equal the same number. They're actually different numbers, so we say that the limit doesn't exist at that point. But notice that right here, if I call this guy, let's say the number B, then the limit as x approaches b from the left and the limit as x approaches b from the right both equal the same number. So in that case, we would say that the limit as x approaches b of this function equals this number L. Notice that f at x doesn't even have to be defined at that point, as in this picture here, f at b is somewhere down here. But I don't care about what's happening at that point. I care about what's happening as I get really close to that point. So let's take a look at this example. It's the same graph that we've seen, but now we're adding numbers to it. So this is the graph of f at x. So in part A, I want to figure out the limit as x approaches 0 of this function. So first, let's find x equals 0. That's going to be right around here, right? X equals 0. So I need to figure out the limit as x approaches 0 from the left-hand side, and the limit as x approaches 0 from the right-hand side. Oh, they both approach the y value or f at x value of 1, so the limit equals 1. It turns out if the function is smooth, so it doesn't break apart at that point, we call that continuous, by the way. So if the function is continuous and smooth right there, the limit as x approaches that number is just going to be the function at that number. Part B, a little bit trickier. Let's take a look at the left-hand limit as x approaches 2 from the left, right-hand limit as x approaches 2 from the right, and then as x approaches 2 in general. So going back to our graph, x equals 2 is right here. So we need to find the limit as it approaches 2 from the left and 2 from the right. Notice that both of these numbers approach the y value or f at x value of 4. So we see that the left-hand limit equals the right-hand limit. They're both 4. So that means that the limit itself is going to be 4. Okay, part C, we're looking at the limit as x approaches 5 from the left, 5 from the right, and then 5 in general. So going back to our graph, x equals 5 is over here. So looking at the limit from the left, I'm following this piece of the graph. I get that the y value, or f at x value, is -1. Following it from the right, so the limit from the right-hand side, I get that the y value is -3. So again, the left-hand limit is -1, right-hand limit is -3. These two guys don't equal, they're not the same number, so then the limit does not exist. Finally, we have part D. We are looking at the limit as x approaches 8 from the left, from the right, and 8 in general. So looking at our graph, 8 is over here. Following the curve from the left, I keep going down forever. Following the curve from the right, again, I keep going down forever. That's what this dotted line means. It's actually something called a vertical asymptote. Don't worry about that right now. We'll talk about it later on in other chapters. So since they both go down, 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 down forever, they don't approach a finite number. In fact, it actually approaches the idea of -infinity, okay? So the limit as x approaches 8 from the left is going to be -infinity, which is not a finite number, so technically it does not exist. Same with the limit as x approaches 8 from the right. It goes down forever, so that's -infinity, and again, it does not exist. Since both of these does not exist, it's this idea of -infinity. The limit as x approaches 8 in general does not exist. So for grade 12 tests and exams, most teachers will want you to write down does not exist. When you go to university, sometimes they will ask you to analyze, does it go to positive infinity, negative infinity, or does not exist in general.